Hello and welcome to this tutorial. Okay, so we are halfway our data preprocessing phase. We learned how to import the libraries, to import the data set. We learned how to take care of missing data. And today we're going to learn how to encode categorical data. So the first thing that we're going to do is that we are going to explain why we need to do this. So I'm going to go to Google Sheets here to find my data set. And in this data set, we can see that we have two categorical variables. We have the country variable here and the purchase variable. These two variables are categorical variables because simply they contain categories. Here the country contains three categories. It's France, Spain, and Germany. And the purchase variable contains two categories, yes and no. So that's why they're called categorical variables. And now you can guess that since machine learning models are based on mathematical equations, you can intuitively understand that it would cause some problem if we keep the text here in the categorical variables in the equations, because we would only want numbers in the equations. So that's why we need to encode the categorical variables, that is to encode the text that we have here into numbers. Okay, so in this tutorial we're going to encode these two variables, country and purchased. We're going to do it in Python and R, and you're going to see that the technique is quite different. So let's start with Python. Alright, so here we are on Python. So as usual, we're going to import a library that will do the job for us, and this library is going to be... this library is going to be the same library as we used to take care of missing data, is the sklearn preprocessing library. So let's just copy this and paste it here. But then we're not going to import the imputer, we're going to import something else, which is label encoder. Alright, so label encoder is a class from the sklearn preprocessing library. So exactly as we did when we took care of missing data, here we need to create a first object of the label encoder class. Okay, so I'm going to call this object label encoder. Okay, so since we're first going to take care of the country categorical variable here, I'm going to call this object label encoder underscore x, and then what I'm simply going to do is I'm going to call the label encoder class. Okay, so we simply need to do this. We simply need to create an object of the label encoder class, and then we're going to use this object on this column country here, which is our categorical variable. Okay, so let's click OK. Okay, so to apply the label encoder object on our column, we will type label encoder underscore x, so that is our object. Then we're going to take a method of the label encoder class, which is the fit transform method, and we are going to apply this method on x, but not the whole matrix x. We just want the first column, and I'm going to let you guess what to put next. We need to put the index of the first column, and we know that indexes in Python start at 0, so the index of the country column is 0. So here we're going to put bracket. We want the whole column, so we here put colon to take all the lines, then comma, and then we put the index, which is 0. Okay, so what we need to understand here is that by typing this line of code, we fitted this label encoder x object to the first column country of our matrix X, and all this returns the first column country of the matrix X encoded. So that means that if I select this and execute, you can see that the output contains the 10 values of the first column of our matrix X, but this time encoded. We no longer have the countries written in text, we have the encoded values of these countries. So now what we need to do is to take the first column here of the matrix X, put it here, so that the first column of this matrix X becomes this array of encoded values of the countries. Because as you can see, if I look at X right now, X, we can see that the first column contains the countries in text, France, Spain, Germany, etc. And now, if I select this line and execute, okay, and if I type X again, okay, now the first column of the X matrix has the encoded values. We can see that France is 0, Spain is 2, and Germany is 1. Okay, so by doing this, we encoded the country column. However, do you suspect any problem that could happen? I will let you think for 10 seconds of what problem could happen here, and I will tell you what this is. Okay, so the problem is still the same. Machine learning models are based on equations, and that's good that we replaced the text by numbers so that we can include the numbers in the equations. However, since 1 is greater than 0 and 2 is greater than 1, the equations in the model will think that Spain has a higher value than Germany and France, and Germany has a higher value than France. And that's not the case. These are actually three categories and there is no relational order between the three. We cannot compare France, Spain, and Germany by saying that Spain is greater than Germany or Germany is greater than France. This wouldn't make any sense. If we had, for example, the variable size with the sizes like small, medium, and large, then yes, we could express orders between the values of this variable because large is greater than medium and medium is greater than small. But here it doesn't make any sense. So we have to prevent the machine learning equations from thinking that Germany is greater than France and Spain is greater than Germany. And to prevent this, we're going to use what are called the dummy variables. That means that instead of having one column here, we're going to have three columns. We're going to have a number of columns equal to the number of categories. So since we have three categories here, France, Spain, and Germany, we're going to have three columns. Each of these three columns will correspond to one country. We're going to have the France column, the Spain column, and the Germany column. And in each column, there's going to be either 1 or 0. So for example, if we are in the France column, it's going to be 1 if the country is France, and 0 if the country is not France. So let's do this. Let's create those dummy variables. To create those dummy variables, we're going to use another class because the label encoder only encodes the values without bothering if there is order or not. So we're going to use another class here, which is the one hot encoder class. Cool name, right? One hot encoder. Okay, and as usual, we're going to create a one hot encoder object. So I'm going to call it one hot encoder equals, so that's the object. And here we're going to call the class one hot encoder with the capitals, one hot encoder, and parentheses, because we're calling the class. And now let's inspect this class. So here I just tapped Command or Control plus I, which means inspect. And if I put that below, we have information about the one hot encoder class. Let's look at the parameters to see what we have to input. Okay, the first parameter is n values. So that's the number of values per feature. We don't really care about that. But an important parameter is the second one, categorical features. Specify what features are treated as categorical. So basically what it means is that we need to specify the index of the columns, that is the column of the categorical variable, which is the country column. It has index number 0. So here we are going to input categorical features equals, in bracket, 0. All right. So that way we specify which column we want to one-hot encode the categories. Okay, so now our object is ready and now we need to fit it to our matrix X. So let's do this. It's really simple. It's kind of the same logic every time. We're going to type X equals because we want to transform X. Then we use our object oneHotEncoder.fit transform. Then in parentheses we type X. And we don't have to only take the first column of X because here we specified the 0 index, so that's fine. And then we just need to add to array and parentheses. Okay, so that will one hot encode the variable X and you will see exactly what it's going to do. Okay, so now we must not forget to reselect and execute this line because we imported a new library which is the one hot encoder. So execute. Okay, and now let's select these two lines and execute. All right, and now let's have a look at X. I'm going to type X here. Or, okay, so maybe it's better to look at it from here. Let's look at it from here. X. All right, I'm going to change the format because I don't want all the decimals. So 3 is the number of decimals, so I'm going to put 0 here to have 0 decimals. Let's click on OK. And here it is. We have 0 decimals. Let's open our dataset too. Okay, so as I told you, the first column here, country, was replaced by 3 columns, these column, and this column, and then we still have our 2 columns, which is the age and the salary. So what I was explaining is that this first column here corresponds to France, this second column here corresponds to Germany, and this third column here corresponds to Spain. So here, for example, let's take the first line. We know that the first line that has index 0 is the country France. And since the first observation is France, then that means that this first column here is going to be 1, because this corresponds to the France column. Then since the second column is Germany, then it's going to be a 0 here because the first observation is France and not Germany. And same for Spain, the third column here is Spain, and it's a 0 because the first observation is France and not Spain. And that is how you encode dummy variables, by making sure that the machine learning models don't attribute an order into the categorical variables. Okay, so let's click on OK here. And now let's take care of the second variable, which is the purchased one. And now be relieved, we won't have to use one-hot encoder. We will just need to use label encoder, because since this is the dependent variable, the machine learning model will know that it's a category and that there is no order between the two. So for the purchased column here, which is the dependent variable, we are only going to use label encoder, and that's what we are going to do. So we're going to do it very quickly. I'm just going to copy this and paste it here. Then we have to create a new object here. So we're going to call it label encoder Y. We cannot use this object label encoder X because this was fitted to the X column here. So that's why we need to create a new object. And here we just need to replace the first column of X by Y, and same as here, Y. And let's not forget to replace X by Y here. And that's ready. We created our object of the label encoder class that will be fitted to Y and that will transform Y into an encoded variable vector. So let's select these 2 lines here and press Command and Control Enter to execute. Here it is. Now let's have a look at Y. Okay, so let's open the dataset first. You see that in the dataset, the purchase column has the 2 categories yes and no. And now if we look at our vector Y, it is encoded, and the label encoder class attributed 0 to no and 1 to yes. Okay, perfect. So congratulations. Now you know how to encode a categorical variable in Python. If you're still not very comfortable with the dummy variable concept, then don't worry, because there will be another explanation in the multiple linear regression section, where we will explain in much more detail the dummy variables by talking about the dummy variable trap. So that was the first explanation, but the intuition is maybe going to get better built later in this course in the multilinear regression section. Okay, and now let's move on to R. So here we are on R. On R, it's actually much more simple, because we won't need to do a one-hot encoding, because we're going to use something very practical in R, that is the factor function. And the factor function will transform your categorical variables into numeric categories, but it will see the variable as factors. And you will be able to choose the labels of those factors. And due to this specific reason, we won't need to create 3 columns for each category. We will just transform the country column into a column of factors, and we're going to specify what the factors are. So let's do this. Let's start by encoding the country column. So we just need to take the column country, and to do this we type dataset $country equals, and then we use the factor function, factor, and in factor we are going to specify 3 things. So let's have a look at the factor function. To do this we click on F1. Okay, so this contains some info about the factor function. Let's look at the arguments. The first argument is the data that we want to transform into factors. So this is of course going to be our country column from our data set. Okay. Then the second parameter is levels, and that's the names of the categories in our country column. So let's add here levels equals. So we're going to write the vector of levels here, C parenthesis, and then we will input here our 3 categories. So that's France, Spain, and Germany. All right. So by the way, C here is a vector in R. So by creating this C, France, Spain, Germany, we are creating a vector of 3 elements, that is France, Spain, and Germany. Okay, and the last argument that we need to input is labels, because we want to choose which number we want to give to France, to Spain, and to Germany. So we're going to add here labels. And then, since we transform our country categorical variable into factors, we don't really care what numbers to use. So let's use 1 for France, 2 for Spain, and 3 for Germany. So this has nothing to do with my preference. It's not because I'm French that I choose 1 for France. It is absolutely non-order relative. So it's just by default that I use 1 to 3. Okay, so that's it. I just forgot one parenthesis, and I think this should disappear. Yes, good. Okay, so the encoding of the country categorical variable is ready. It's actually more simple than in Python. So before selecting and executing this, let's look at our data set. Our data set contains our country written in text. And now let's select this, execute, and now let's look at our data set. Perfect. Our country contains our encoded variable. And as you can see, 1 is France, 2 is Spain, and 3 is Germany. Okay, so that's all good. And now we need to do the same for the purchase column. And it's exactly the same. We're going to use the factor function. We're going to transform the text categories into numerical labels. So let's do it right now. We're going to copy this, paste it here. Here we're going to replace country by purchased. All right. Same for here. Here we need to change the levels because there are new categories. So the levels are going to be no and yes. Okay, and now of course we need to change the labels. So we're gonna put 0 for no and 1 for yes. I think that's what actually makes sense. And parenthesis. Okay, and that's ready. Let's look at the data set. The data set contains no and yes in the purchase column. And now if I select this and execute, the data set contains now 0 and 1. Perfect. We're all good. We encoded our categorical data in R, and now you know everything that there is to know about encoding categorical data in Python and R. So congratulations. I know this was quite a long tutorial, but we almost did the most difficult part. We are approaching soon the fun and exciting part about making models. So we are almost there. Hang on for 1 or 2 more tutorials, and this is gonna get very exciting. Thank you for watching this tutorial, and I look forward to seeing you in the next tutorial. Until then, enjoy machine learning.